Hi everybody, so in this video I'm going to show you how to perform reflections using matrices. So in this example we've been asked to reflect triangle ABC, which is this triangle here, in the line x equals 0, or the y-axis. And before I show you how to do this using matrices, I want to show you what the reflection would look like using Desmos. So we have our object, which is this triangle ABC. If we draw a box around this, and select transform and then reflect, and we'll use a y-axis, we'll just label the vertices on this created image. And you can see that triangle DEF is the reflected image of our object. So I'll copy and paste this into our presentation. So triangle ABC is our object and triangle DEF is our image. And we're going to reflect this triangle using matrices to create this image, and we'll use the points D, E and F to check our transformation is correct. To create our transformation matrix, we need to use the unit-based vectors I and j. We know I originates from the origin and has coordinates 1, 0, and j originates from the origin and has coordinates 0, 1. So rather than reflecting each of these vertices, what we'll do is we'll reflect I and j in the y-axis. So when we reflect I, the transformed coordinates become -1 and 0. We'll call this I dash. And when we reflect j in the y-axis, this point becomes invariant. And this means it is transformed onto itself. And it is these transformed coordinates for I and j that give us our reflection matrix. So this is -1, 0 for our I coordinate and 0, 1 for our transformed j coordinate. To create the image, we multiply this reflection matrix by the coordinates of each of the vertices in the object. So if we look at coordinate A, this has an x value of 2 and a y value of 2. So this becomes 2 and 2. We'll look at coordinate B. This is an x value of 2 and a y value of 6. And coordinate C, an x value of 4 and a y value of 2. So we multiply the reflection matrix by the vertices of the object, and this product will give us the vertices of the image. And I showed you in a previous video how we multiply matrices together. But in this video, we're going to perform this on a calculator. So we'll go to our calculator, we'll press menu, option 4 for matrices, then we need to define matrix A, so option 1, as our reflection matrix. And this has 2 rows and 2 columns. The elements are -1, 0, 0, and 1. Then we'll define matrix B as the vertices of the object. This has 2 rows and 3 columns. And the x coordinates are 2, 2, and 4. And the y coordinates are 2, 6, and 2. So then we'll go back to option. We'll choose option 3 for matrix calculations. And then we want to multiply matrix A by matrix B. And this will give us the corresponding vertices of the image, which are -2 and 2, -2 and 6, and -4 and 2. And we can check these. -2 and 2 is at D. -2 and 6 is at E. And -4 and +2 is at F. Okay? In the next question, we're going to look at reflecting in the line y equals x. Okay, so we've been asked to reflect triangle ABC in the line y equals x. To show you what this would look like, we have the transformed image here. So we'll label ABC as the object and EFG as the image, the transformed image. And then you want to try and transform this object onto the image using matrices yourself. You can pause the video, and when you come back, we'll go through the work solution. Okay, so welcome back if you had a go. So the first thing we need to do is we need to find our transformation matrix. And we're doing this using the unit-based vectors I and j. We know I has coordinates 1, 0. And when you reflect this in the line y equals x, then this point is reflected through the mirror line to here. So the image of I has coordinates of 0, 1. And we transform j, which has coordinates 0, 1, reflected in the line y equals x, is reflected to this point at 1, 0. So I'll just underline the transformed images of I and j. We've got 0, 1 and 1, 0. So our reflection matrix is 0, 1 for I and 1, 0 for j. Then we'll multiply this by the vertices of the object, which are for A, 6 and 2, for B, 2 and 0, and for C, 6 and 4. And this product will give us the vertices of the image. And again, I'll perform this using a calculator. So we'll go back to our calculators. We'll choose option. We'll redefine matrix A as our new reflection matrix, so 2 rows and 2 columns, with the elements of 0, 1, 1 and 0. We'll redefine matrix B with the x coordinates of 6, 2 and 6, and y coordinates of 2, 0 and 4. We'll go back to option, matrix calculations. We want matrix A multiplied by matrix B, and we get the vertices of the image as 2, 6, 0, 2 and 4, 6, and we'll just check this works. So 2, 6 gives us point G, 0, 2 gives us point E, and 4, 6 gives us point F. Okay. Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe, and you can download the full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below.